What if a massive solar superflare hit Earth today? It would be like a giant EMP grenade exploding so hard, knocking out satellites, power grids, and all technology worldwide. A solar superflare caused the mysterious cosmic blast back in 774 AD, leaving a hidden mark in ancient tree rings. Scientists warn this could happen again. Let's find out what that means for our modern world. In the year 774 AD, something invisible hit Earth. No one saw it. No one heard it. But it changed our planet forever. It wasn't a meteor crash. It wasn't a volcanic eruption. Life seemed normal, yet something massive had happened. The evidence was hidden in trees. Trees are time machines. Every ring inside them tells a story of the year it grew. Thicker rings mean good growing seasons. Thinner rings mean harder times. But tree rings also record cosmic events. The secret lies in a rare form of carbon, carbon-14. Carbon-14 is a radioactive isotope of carbon used to determine the age of once-living things through radiocarbon dating. Normally, carbon-14 forms when cosmic rays from space slam into nitrogen atoms high in Earth's atmosphere. These rays are tiny, high-energy particles that constantly rain down on our planet from space. They transform nitrogen into carbon-14. Plants absorb it. Animals eat plants. And so carbon-14 ends up in everything alive, including the rings of trees. Scientists use this to measure the ages of ancient objects. It's called radiocarbon dating. But sometimes carbon-14 spikes reveal something else, massive bursts of cosmic radiation. In 2012, Japanese researcher Fusa Miyake was analyzing tree rings from ancient cedars. What she found shocked the scientific world. The ring for 774 AD contained a sudden 12% jump in carbon-14. That's enormous. Normal fluctuations are tiny, fractions of a percent. Something had flooded Earth with cosmic rays stronger than anything measured in human history. This became known as the Miyake Event. Since then, scientists have found more Miyake events scattered across the last 10,000 years. But 774 AD remains the strongest spike ever recorded. What could cause such an explosion of energy? Three main suspects emerged: a solar superflare, a gamma-ray burst, or a nearby supernova. A solar flare is a sudden eruption from our sun. Most are harmless, but superflares are monstrous, thousands of times more powerful. Astronomers have seen superflares on other stars. Some are so violent they could strip entire planets of their atmospheres. If one hit Earth, it could easily explain the 774 spike. The second suspect, a gamma-ray burst, the most violent explosion known to science, caused when massive stars collapse or neutron stars collide. In seconds, a gamma-ray burst releases more energy than our sun will produce in its entire lifetime. If one happened close enough and pointed at Earth, it could create a Miyake event. The third suspect, a supernova. When a star explodes, it floods space with cosmic rays. A nearby supernova could also fit the data, but none has been identified from that period. Right now, scientists lean toward the solar superflare theory, but no one knows for sure. All we know is these events are natural and they will happen again. In 774 AD, no one noticed. There were no satellites to fry, no power grids to destroy. Life simply went on. Today, things would be very different. A Miyake event could knock out satellites, cripple navigation systems, and destroy parts of the global power grid. To understand how dangerous this could be, we must look deeper into how these cosmic events work and what history can teach us about surviving them. To grasp the scale of a Miyake event, let's explore what each cosmic culprit really means. Start with solar flares. Our sun constantly sends out light and particles, but sometimes it erupts in violent bursts of energy. The largest solar storm in recorded history was the Carrington event of 1859. It was so powerful that telegraph lines sparked and auroras were seen near the equator. If a Carrington-level storm struck today, experts estimate trillions of dollars in damage. But a Miyake event was far stronger than Carrington. Superflares seen on other stars can release thousands of times more energy. Our sun is calmer than most, but it's not impossible it could unleash one. Then there are gamma-ray bursts. Imagine two neutron stars colliding, the densest objects in the universe smashing together. The resulting beam of energy travels across galaxies at nearly the speed of light. If pointed at Earth, it could devastate our atmosphere. Luckily, gamma-ray bursts near Earth are rare. Still, even a weaker one, farther away but still aligned with us, might leave a signature like the 774 spike. Finally, supernovae. When a massive star dies, its explosion floods space with high-energy particles. A supernova within 30 light-years could double or triple cosmic radiation on Earth. But again, no clear candidate from 774 AD has been found. So scientists search for answers. They study ancient trees from every continent, ice cores from Greenland and Antarctica, and coral reefs that record chemical traces of space weather. Each new record adds detail to a cosmic timeline, a map of when Earth has been hit by these invisible storms. Current evidence suggests Miyake events happen roughly once every 1,000 years. But roughly is the key word. Nature doesn't follow our schedules. We might be centuries away from the next one. Or it could arrive tomorrow without warning. What would that mean for us? Satellites could be disabled, knocking out GPS, internet, and global communication. Power grids could experience surges strong enough to destroy transformers. Blackouts could last months, even years. Aviation and shipping could lose navigation systems. Emergency response networks could collapse just when they're needed most. And because cosmic rays penetrate our atmosphere, even astronauts in orbit would face dangerous radiation levels. The good news? We can prepare. Researchers are developing early warning systems to detect extreme solar activity before it hits Earth. Engineers are designing power grids that can resist geomagnetic storms. Satellites are being built with better shielding. But understanding is the first step. The Miyake event of 774 AD reminds us that Earth is part of a much larger system, one we cannot control but can learn to live with. Cosmic forces don't care about our technology. They don't care about our borders or our plans. They simply happen. And yet, by reading the stories in tree rings, ice, and stone, we are beginning to understand them. The question is not whether another Miyake event will happen. It's when. And whether we'll be ready when it does. If you're fascinated by the mysteries of space and time, don't forget to like, subscribe, and hit the bell so you never miss a mind-bending journey. Join us on Bronze and Bananas, where science gets wild.